Right, this is the third video on question 1. Question 1 is based on 4 planes defined with these conditions. There is plane 1, there is plane 2, there is plane 3, and there is plane 4. This question is based on plane 3, the last in number 1. We actually modified it slightly from the one that is in the lecture notes. So the one is in the lecture notes is as shown in pink here. So it just wants the intercepts of plane 3 with the coordinate axis. We added coordinate planes as well. So we're going to start by working this out. Then we're going to work this out. So the form of the equation of plane 3, which is efficient to do this, is the scalar form of the equation pi 3. So let's see if we can find it. This side. So pi 3, the scalar form of the equation there, it is, or did we already have it? Yes, we already have it this side. Okay, so now so this is example number E. So before we do this, let's just explain. So we're going to start with the intercepts with the coordinate axes. So coordinate axes, or intercepts with the coordinate axes. Okay, we're just going to explain both of them, and then we're going to start with the intercepts with the axis. So these are our coordinate axes, x, y, and z, and we just take a slice of the plane in this first octant. It will look something like this. So that is a possible, so that is our plane. Okay, so the intercepts with the coordinate axes are simply the coordinates of these 3 points here. Okay, we are just going to do one of them, and then the calculation for the others is pretty much the same. So let's do the intercept with the x-axis. Well, the first thing to note, so though that's the y-axis, so if y here, y is 0. Well, because we're going to be coming this way. Okay, if y here and coming this way, so along the x-axis both y and z are 0. Okay, so all we need to do is to go to the scalar equation, plug in 0 here, plug in 0 there, then we're going to get the x coordinate. So we can see that's going to be 2x is equals to 8. So x is 4. So the intercept of this plane with the x-axis is going to be 4, 0, 0. The intercept of this plane with the y-axis, so in this case we're going to plug in x is 0 and z is 0. So x is 0, z is 0. It's going to give us y is -2. So it's going to be 0, -2, 0. which means it's actually not this side, it's actually the other side, the negative side of the y-axis. And then you can do the same thing for the z-axis. Now, the intercepts with the planes, the coordinate planes. So there are 3 planes. Do another sketch. So there are 3 planes. The horizontal plane, this one here, is the xy plane, and that one is defined by z equals to 0. Okay, then there are 2 vertical planes. This one here is the xz plane, and then the last one is this one here, that's the yz plane. Now you can see that the intersection of the plane with those planes is a straight line. Okay, in 3D we already talked about equations of straight lines. So that's the intersection of the plane with the xz plane. That's the intersection of the plane with the xy plane. That's the intersection of the plane with the yz plane. So intersection between any 2 planes is always going to be a straight line. So we've got one plane here, and we've got another plane there, and this is the line of intersection. It's a bit like the spine of a book. That's the intersection of all the pages, and it's going to be a straight line. So let's just do the intersection of the plane with the xy plane. So it's the intersection of the plane pi 3 with the xy plane. The xy plane is defined by z equals to 0. Okay, so want the intersection of this with z equals to 0. Okay, so we simply plug in z equals to 0 there. What happened there? That should be 2x minus 4y. Okay, so this is simply going to give us 2x minus 4y. That's not equal to 0, that's equal to 8. Okay, that's equal to 8 there. Okay, so if we plug in z equals to 0, that's going to give us 2x minus 4y is equal to 8. Now, as you can see, that is a straight line. The way that we know about straight lines in 2D. Okay, so then what we can do here, we can either make x the subject of the formula or y the subject of the formula, so that we don't have any fractions. I'm going to make x the subject of the formula. So this is going to be x is 4 minus 2y. Okay, if you make y the subject of the formula, it's going to be equally correct. So this line, let's call it L, is defined by z equals to 0, comma, x equals to 4 minus 2y. Now, when we did straight lines in 3D, we said that there are three forms of the equation. There is the vector form, there is the parametric form, there is the symmetric form. So I'm going to derive all three from these two equations. First, I'm going to start with the parametric form. Okay, so parametric form, we are going to introduce a parameter, and we are going to introduce the parameter t. We're going to say let y be a parameter t. That's this y here. Then x is equals to 4 minus 2t. Z we already have here. That is a parametric equation, if you like. But I'm going to write it in the form 0 plus 0t. I'm going to rephrase this one. 0 plus t. And so we have parametric form of the equation of this straight line here, this one here, intersection of pi 3 with the xy plane. Then from the parametric form, we can convert this easily into the vectorial form. So it means xyz is going to be 4, 0, 0 plus t into minus 2, 1, 0. So that's already the vector form of the equation. The symmetric form, we eliminate t here. So if we eliminate t from the first equation, we're going to find that t is equals to y. From the second equation, we're going to find that t is 4 minus x all over 2. And then z, there is no t in the equation for z. So z, we're just going to write z equals to 0. Now, in fact, this equation is just that equation there. Okay, and so we've got the three forms of the equation of that straight line. Okay, the next video we're going to do examples number 2 and number 3.